series work. Without Dr. Zarkov, there would be no rocket ship, no trips to Mongo, no saving Earth. Heroics aside, without science, there is no science fiction. I came to realize that these tales were simply impossible in terms of the science involved, just flights of the imagination. Growing up meant putting away such fantasy. In real life, I was told, one had to abandon the impossible and embrace the practical. However, I concluded that if I was to continue my fascination with the impossible, the key was through the realm of physics. Without a solid background in advanced physics, I would be forever speculating about futuristic technologies without understanding whether or not they were possible. I realized I needed to immerse myself in advanced mathematics and learn theoretical physics, so that is what I did. In high school, for my science fair project, I assembled an atom smasher in my mom's garage. I went to the Westinghouse Company and gathered 400 pounds of scrap transformer steel. Over Christmas, I wound 22 miles of copper wire on the high school football field. Eventually, I built a 2.3 million electron-volt Betatron particle accelerator, which consumed 6 kilowatts of power, the entire output of my house, and generated a magnetic field of 20,000 times the Earth's magnetic field. The goal was to generate a beam of gamma rays powerful enough to create antimatter. My science fair project took me to the National Science Fair and eventually fulfilled my dream, winning a scholarship to Harvard, where I could finally pursue my goal of becoming a theoretical physicist and follow in the footsteps of my role model, Albert Einstein. Today, I receive emails from science fiction writers and screenwriters asking me to help them sharpen their own tales by exploring the limits of the laws of physics. The impossible is relative. As a physicist, I have learned that the impossible is often a relative term. Growing up, I remember my teacher one day walking up to the map of the Earth on the wall and pointing out the coastlines of South America and Africa. Wasn't it an odd coincidence, she said, that the two coastlines fit together, almost like a jigsaw puzzle? Some scientists, she said, speculated that perhaps they were once part of the same vast continent. But that was silly. No force could possibly push two gigantic continents apart. Such thinking was impossible, she concluded. Later that year, we studied the dinosaurs. Wasn't it strange, our teacher told us, that the dinosaurs dominated the Earth for millions of years, and then one day, they all vanished. No one knew why they had all died off. Some paleontologists thought that maybe a meteor from space had killed them, but that was impossible, more in the realm of science fiction. Today, we now know that through plate tectonics, the continents do move, and that 65 million years ago, a gigantic meteor measuring 6 miles across most likely did obliterate the dinosaurs and much of life on Earth. In my own short lifetime, I have seen the seemingly impossible become established scientific fact over and over again. So is it impossible to think we might one day be able to teleport ourselves from one place to another? Or build a spaceship that will one day take us light years away to the stars? Normally, such feats would be considered impossible by today's physicists. Might they become possible within a few centuries? Or in 10,000 years, when our technology is more advanced? Or in 1,000,000 years? To put it another way, if we were to somehow encounter a civilization 1,000,000 years more advanced than ours, would their everyday technology appear to be magic to us? That, at its heart, is one of the central questions running through this book. Just because something is impossible today, will it remain impossible centuries or millions of years into the future? Given the remarkable advances in science in the past century, especially the creation of the quantum theory and general relativity, it is now possible to give rough estimates of when, if ever, some of these fantastic technologies may be realized. With the coming of even more advanced theories, such as string theory, even concepts bordering on science fiction, such as time travel and parallel universes, are now being re-evaluated by physicists. Think back 150 years to those technological advances that were declared impossible by scientists at the time, and that have now become part of our everyday lives. Jules Verne wrote a novel in 1863, Paris in the 20th Century, which was locked away and forgotten for over a century until it was accidentally discovered by his great-grandson and published for the first time in 1994. In it, Verne predicted what Paris might look like in the year 1960. His novel was filled with technology that was clearly considered impossible in the 19th century, including fax machines, a worldwide communications network, glass skyscrapers, gas-powered automobiles, and high-speed elevated trains. Not surprisingly, Verne could make such stunningly accurate predictions because he was immersed in the world of science, picking the brains of scientists around him. A deep appreciation for the fundamentals of science allowed him to make such startling predictions. Sadly, some of the greatest scientists of the 19th century took the opposite position and declared any number of technologies to be hopelessly impossible. Lord Kelvin, perhaps the most prominent physicist of the Victorian era, he is buried next to Isaac Newton in Westminster Abbey, declared that heavier-than-air devices such as the airplane were impossible. He thought X-rays were a hoax and that radio had no future. Lord Rutherford, who discovered the nucleus of the atom, dismissed the possibility of building an atomic bomb, comparing it to moonshine. Chemists of the 19th century declared the search for the philosopher's stone, a fabled substance that can turn lead into gold, a scientific dead end. 19th century chemistry was based on the fundamental immutability of the elements, like lead. Yet with today's atom smashers, we can, in principle, turn lead atoms into gold. Think how fantastic today's televisions, computers, and internet would have seemed at the turn of the 20th century. More recently, black holes were once considered to be science fiction. Einstein himself wrote a paper in 1939 that proved that black holes could never form. Yet today, the Hubble Space Telescope and the Chandra X-ray Telescope have revealed thousands of black holes in space. The reason that these technologies were deemed impossibilities is that the basic laws of physics and science were not known in the 19th century and the early part of the 20th. Given the huge gaps in the understanding of science at the time, especially at the atomic level, it's no wonder such advances were considered impossible. Studying the impossible. Ironically, the serious study of the impossible has frequently opened up rich and entirely unexpected domains of science. For example, over the centuries, the frustrating and futile search for a perpetual motion machine led physicists to conclude that such a machine was impossible, forcing them to postulate the conservation of energy and the three laws of thermodynamics. Thus, the futile search to build perpetual motion machines helped to open up an entirely new field of thermodynamics, which in part laid the foundation of the steam engine, the machine age, and the modern industrial society. At the end of the 19th century, scientists decided that it was impossible for the Earth to be billions of years old. Lord Kelvin declared flatly that a molten Earth would cool down in 20 to 40 million years, contradicting the geologists and Darwinian biologists who claimed that the Earth might be billions of years old. The impossible was finally proven to be possible with the discovery of the nuclear force by Madame Curie and others, showing how the center of the Earth, heated by radioactive decay, could indeed be kept molten for billions of years. We ignore the impossible at our peril. In the 1920s and 1930s, Robert Goddard, the father of modern rocketry, was the subject of intense criticism by those who thought that rockets could never travel in